Hi, everyone. Thanks for joining the session. Welcome to day one, session two of our machine learning series. We conducted day zero some time back and had the recording corrupted and apologize for that. So I re-recorded the video and updated it on YouTube channel. Please visit and subscribe. And first, let me introduce myself. I'm Maitreyi Sinha Chaudhary, a tech enthusiast. And Chrysalis is a knowledge sharing platform focused on technology, primarily data, ML, AI, and possibly other emerging aspects of technology such as IoT. So, as a way to giving back, I share my knowledge and expertise here, and also open to other in community to share their knowledge. So, you know, um, definitely would be open for that. You can reach out to me. Few points before we get started. So, first of all, I'd like to state what we are not. We're not a training organization that sells any paid course, not even in future, hopefully. And we will not involve any financial transaction for engaging anyone for sharing their knowledge as well. And also, I'd like to share one fear that I was compiling the whole subject. I'm worried that 1 hour may not be sufficient or justified. So we can explore. I mean, we'll see how far we reach by 1 hour, and if it is going beyond, and you guys, it's too much for you guys, which it will be. We can make a decision together whether I would like to. I mean, I would share a video with you later on, or you'd like to come back for a session, which is part two of session two, or we can make a you know feasible choice as we reach towards the end of 1 hour. Let's see. So let's get started. Yeah. So I'd like to set some expectations. Like that would be very important for this setup. One is what not to expect out of this class. It's important to know. One, it's not a Python class. So I'm not teaching you Python here. It's not a coding class either. So if you're thinking that I will, yeah, if you require a Python series that I can come up with, but this session is not for that. It's not hands-on job execution class. Just to be aware of that. So if anyone has that expectation, please, set it up, understand how it's going to be. Setting up environment is not objective of this class. Again, if you're required to understand that because you're very new, I completely appreciate. I can go ahead and maybe upload a video on the YouTube that you can actually, find useful. This class is not for advanced users unless they need a refresher. So there will be a lot of conversations. A lot of experts may feel, oh, you know what? I already know why she's talking about that. I'm talking about this because ideally it is for people who are not as well versed as an advanced ML user would be. What to expect? We will walk through end-to-end ML implementation scenario with an example use case, exactly when you are faced with a problem statement like this, how to kind of tackle this problem in a structured manner, right from point zero to the point last, basically point 100 or whatever you call it, right? It's a lot of work. This should help you with the structured approach, as I just talked about, solving a business problem execution approach. Use cases taken from real life experience, few other books, combination of both. So it's like common example of housing price prediction. It is not something that, even though the content I'm owning because I'm building it, but am I owning the use case and the data set and the scenario? No, it is very much available. If somebody wants to understand using this, how to tackle other business problems, definitely it can be. As I said, the data is used from publicly available library, even though I will actually give the data, ready-made, but just for you to be able to run it. So don't worry, data is, you will get that data, raw data available with you. So I think we're good there. This session is for beginners with basic Python and statistical knowledge. So I'm expecting that you have some idea of Python, some idea of statistical knowledge. And if not, I can help you with that too. Post session deliverable. What to expect? Recording of the lecture will be shared to our YouTube channel on meetup message. The PDF note will be shared with all the subscribers. I'm sorry, I will only share it with the subscribers. Jupyter Notebook through my GitHub link will also be shared with the subscribers. If there is any feedback, comments, queries can be shared through our channel. I mean the YouTube channel. I'll share that. Share your feedback, comments. You know, if you think that there is something that you need from me that that probably will be helpful. If I can help, I'll help you through that reach. Chat box may not help with specific query. As I said, first of all, there will be less engagement today, primarily because last time there was a high engagement. It was almost a conversation, but this time it's going to be tough because a lot to cover, a lot. There are almost 80 slides. I can engage here for instant conversation. Something comes to me, right? So some may feel I skipped their queries, did not answer them. Please, that's not true. Because when I'm focusing on working with you, talking to you, I am not able to focus on the chat boxes or the queries coming up on the chat boxes. Please apologize. I mean, forgive me for that. I apologize. Now, ideally, so this is my, let's talk about, what's my recap. Last time when we had a day zero, we had few recaps, right? We discussed basic understanding on the AI, ML, and DL. We did discuss relation and difference among AI, ML, DL with examples. We also used why we use ML and where ML really fits. We also discussed basic terminologies within machine learning, 4 pillars of AI's data set, model architecture, ML framework, and then what is the other one? We discussed the hardware. So these are the 4 areas that we discussed, right? So ideally, we did a lot of conversations on this one, right? And let me share. I'll share, that link. Real life examples of AI ML usage. Also, I shared high level ML implementation steps. And this session is purely on this point, high level. There was one slide, but here we have 80 slides on that. So responsible AI, very surface level because it's a very deep topic. So just gave a little bit of a glance on the responsible AI. Link to day zero session as follows. I will share that. Okay. Let's talk about it. Now, what are we going to talk about today? We're going to talk about high-level ML implementation steps. Exactly what we talked about. The roles and processes involved in the ML implementation steps. Right? So we are good there. Deep dive of above high-level steps with interim steps with public data set. We have used housing. We're going to, the example use case is going to be on house pricing prediction. Publicly available data set is available in the Kaggle, but I will anyway share it through my, so that you don't have to crawl or, unzip and all that. So I'm directly will share the file. Prediction example code snippets, problem statement to serving the entire end to end. And I know that it's gonna be a lot today, but then I will be nice, I'll be kind. If you think that it's getting too much, we can see. I will take a pause and then we will make a decision. Okay, so let's discuss what's our high level ML implementation steps. Last time we discussed, right? So roughly we can say let's say there are 8 steps roughly. So I'm excluding MLOps principles here. It's not covered today in this use case. But what are the steps that are performed, overall end to end? As I say, the big picture is this is the step that focuses on some sub steps which are necessary for framing the problem statement, right? Objectivity of the solution, and it's very important even before any data or coding is involved. Do not start writing a code just because you know how to write Python and just because you know how to use Jupyter. Don't start writing anything ever. So this is the strategy, portion of your work. And I will go deep into it. It is not one liner. There are data collection and system design step that comes in as a next step. What happens? Right? This is the step where you plan, strategize, and collect relevant data and identify if it's own, if it's at all an ML problem, right? So, um, even if it is, what kind of algorithm that to be, system, yes, part of the system design, you're figuring it out, what kind of algorithm to work with. So, and also decide on the four AI pillars that I just talked about: data, model architecture, ML framework. What will you do? So, those decisions are made at this stage. You're not using those, you're making decisions around those at this step. Now that you, and at this step, you have collected your data as well, because next step, you're going to focus on ED and sampling, so which is nothing but your exploratory data analysis. Now, are you going to start your analysis right away? No, right? You will get in details and the sampling for creating and training test set. What is training set? What your model learns from, and test set, what your model performance is measured out of. Basically, your evaluation and all of that done using test set. So I'll go into the details as of today, right? Next is your data cleanup and transformation. This step involves multiple strategies to clean up and transform the data that you are feeding your model architecture using different ML frameworks. So a clean, well sampled data can be fed to your model. Just consider, like, when you have a little baby, what you do. A lot of you may be having your baby already. So you would ensure there are safety measures taken, right? Before you have handed the bottle to your baby, right? So you're going to do a lot of cleanups, treatments, and transformation as a pre um, training satisfying safety measures, right? So next is your model selection. Model selection, train, fine tune, right? And we'll go into the deeper in those for those. Next step is serving the model when it is ready to predict. It could be directly used in an app or used into a model that goes into another app. That is a possibility, right? And then finally, monitor, which basically, just not just monitors, launch, deploy, monitor, improves, maintain, right? And then finally, solution, which is through which you have served. So based on, you know, you can say the serving strategy that you have. It's aligning with that. So far with me? All right. Now, next step. I just discussed that execution layout by roles involved, right? So now that we browse through high level steps involved, I mean, we just discussed what are the block level activities in sequence. So we also must talk about what are the different roles involved in those cases, right? I mean, ideally, let's quickly discuss which different roles that and teams get involved, in all these phases. So, as you can see from the swim lane, the two teams work primarily closely: data engineer, data scientist, machine learning. So, data scientist may be a data engineer as well. I'm not denying that, but ideally, it is two different teams. So, for a data scientist to start working with, their relevant model, for before using it in their model, they require the data to be available to them in a certain format. But the data may not be available in that same format. So there has to be a collaboration with data engineering teams, who may be collecting the information from different sources, and then deliver that information in a certain desired format and frequency to the data scientist team. And the data scientist and machine learning engineer may be again the same person, but usually it is same team or even the same person, but data scientist more focuses on the exploration of the data. That's why they're scientists. The experimentation that happens with a data scientist hat. But after the model is deployed, then there is a different kind of engagement starts. And that's where an ML engineer comes into place. And that's primarily focused on the um, orchestration of the ML, which we will not cover 100% because that'll be like, that'll not be possible in this session. But ideally, what I'm trying to say that we will discuss everything up to you serve the model, because ML ops comes after you have served your model, right? So here we are talking up to you serve the model. Okay, so let's move on. We good? Please, if you have any question, you can reach out to me. But today, I don't think I can, carry on, right? So let's see that what's happening. We take the first big picture right now, right? So far with me, this is the first block we discussed. So we're starting with the step where everything starts, right? Let's move on. So what do we do? In this step one, there is a level 0 before you and everything counts. First thing that we want to do, what we want to achieve. What is my highest level statement, right? Now, in this context of housing price prediction, let's say your boss or your stakeholder or your customer comes to you and says, we want to model housing prices for United States, California state based on available jurisdiction data on housing prices. So ideally, I have some data. What he's meaning is that I have some data on the California jurisdiction and the housing prices for last these many years or whatever. And based on that, you should be able to come up with a, you know, predicted median housing price, per jurisdiction, per district, so that I can use it for my, business growth or next, you know, strategic direction, right? Now, with that, so it's basically the state where you are asking or getting to know what is expected, right? Now, at this point, there is no code, no model, no data, no ML jargon. Think of only the problem. You are not going to touch any code, model, data, nothing at this point. Next is your, right? Basically, you are trying to figure it out, the business objective, right? So you're asking, like, why? What is the reason I'm doing it? So far, you got to know from your boss or customer, yeah, I want to do this. I want to model housing price. I want to predict housing price. Now, you have a business question in your mind. This is the next step where you want to know why you want to do it. What is the business objective? Why do I need to pricing model for houses or districts, right? You get an answer that we want to be able to predict housing prices across similar jurisdictions. So we need pricing model that is effective. So ideally, this is a business reason. If I am able to get to know the proper pricing, then I would be able to receive a proper positioning in the market. So you get to know that okay, business has a reason to ask for it. So generally, whenever you do anything, don't just know what to do, also want to know why to do it. Then your next question becomes very important question, right? how am I going to use, how this data is going to be used, right? So, same thing, how this model is going to be used. So the predicted median price for jurisdiction based on available data is going to be either used directly in pricing prediction app, direct embedding for a model, or it can be an input to another, as an influencing factor to another outcome or another target variable, where that app can probably suggest or come up with an investment plan. So what I'm trying to say, it can be your model can be directly used, or it can be a indirect utilization as well. So now that you got to know what, got to know why, you got to know how is it going to be used. Next important is, and also it talks about the app will be served to stakeholders through either SaaS or any SaaS based web app or mobile app. So it's going to be used that way, right? So now you want to talk about benchmarking, right? So now that you know what, why, how it will be used, and then you step back and find out, why am I doing it, instead of the existing process? What is it going to improve? What is my achievement by doing this? So you want to benchmark all your processes. Like, ideally, you'd like to see the current process, metrics, outcome, understand the current method. You get to know that it's a manually done process. And, currently, what's the prediction accuracy that is currently in place? Probably you get to know that there is always a 20% offset. Prediction accuracy is not so great. What decides the benchmark of correct median price for houses, right? So when you say, which basically means we must know a reference point, as in, if I am predicting the price is X, how do I know what's the right price that it is supposed to be? Who tells me the existing benchmarks that so far we have? So your stakeholder says, hey, you know what? I have some data available that tells you what the actual prices have been. So you can use that as a reference point. See, right now you got a supervised learning. I just talked about. You got to know. You already right now you know it's a supervised learning. You're comparing this against the reference point, right? Let's move on. Deep dive of steps with use case examples, right? Assumptions. Now, after you benchmarked, there are a few assumptions that you need to make. That what are those assumptions? Like, what is your operating condition, right? As in, you may or may not have access to everything. So let's understand what. And these are just examples. There could be more assumptions that you may need to set. So, what data is usable and protected under data protection law? Is the training data quality good? I will get data in a certain structure and format. What are those? Etc. There could be even more important assumptions such as who are the drivers, who will be funding this, blah blah. I'm not getting into all of that, but in real life scenario, when you're actually delivering a project like this, you would have these questions, right? So next, who are important people, experts and stakeholders, right? Who can I connect with? Find out who all you need to connect and work with. Stopping, for example, who owns the data, who will approve the access, who knows the business process to explain the KPIs. Remember, you need to understand your data. You need to understand the business process and how the data and the business process are connected to each other. What are the KPIs that are relevant, right? So you need to know all of that. So who can help with different factors that impact the pricing model? But at the moment, you understood that the business is interested in the pricing. And so ideally, you know that that is what he or she wants to get predicted. So these are etc. There are many more. That's possibility. When you get into the situation, you know what to ask, what to think about. So ideally, so far, what you have done, step 1, level 5 up to. So within the step 1 itself, you have already come through 5 steps. You have framed the problem statement, the what part. You've asked what's the business objective, the why part. You have discussed how the model will be used and how it will be served. That is your basically your kind of one portion of the how part. Then you come back and you figure out some of the set some benchmarks so that you can see as a value how your project I mean where you would show that your project actually delivered a value, right? So you have to have a benchmarking, it's as a very initial stage. Then you have to have what? You have to have assumptions. After you're setting the assumptions, and assumptions can be any kind of assumptions, right? And then you are trying to identify what who are the important people that you need to work with, experts and stakeholders, because it's not just the it's not just the important people. It's also about the people who are right on the ground, the people on the floor. They can tell you much more than actually a manager or an executive sponsor will be able to tell you, right? So you need to know the SMEs, as I say, the experts. Then you talk about here you are just asking questions. Now you stop asking questions and you start introspect. So what kind of modeling problem is? Looking at the problem statement, find out what kind of model is needed. Now, are you going to be selecting the model right away? No. But what kind of question mark? First of all, you've got to know, I just discussed, it's a supervised because you're getting some reference point. Do you want to know, you want to predict median housing price value? So you're predicting a value. So it's a regression. If you also clarify whether they want to have a predict a value or they want to category of that median house price, like high price, low price, medium price, is that how he wants it to be? You figure out. No, he said, no, I'm okay with actual value and I don't need a category of it. So it's not going to be a classification problem, it's going to be a regression problem. Here you are not coding anything. Remember, you are simply doing your initial, it's like you're sitting with a notebook and just scribbling and not doing any coding. Okay, it's important to scribble. So does it need ML at all? Another question is, can I apply simple logic, business logic, and come up with these predictions, or it does need an ML? So in this case, you know that you need ML because um, looking at the data, you won't be able to just apply a logic. It has to be ML. Does it need ML or DL? You're dealing with the structured information, so ideally it is an ML problem. Right? So there could be a lot of other questions that you can come up with, but this is a question that you are kind of you're jogging your own mind and trying to come up with. So he is going to be a value prediction that is going to be used in another model, which would predict the feasibility of investment in housing market. So you have gathered a lot of, but don't do overthinking, guys. Okay, overthinking is not good. Your thinking should be structured, and that's what you're doing right now. Right now, model performance measure. Now that you have got everything, I mean everything in terms of problem statement and everything, you have some of your important questions answered. You probably have set the ball rolling for some of the areas where you need permits or permission granted, which usually takes a lot of time. So you have kind of set the ball rolling in multiple areas. Now you're trying to find out how am I gonna measure my model performance, right? With all of that, so just say problem statement, limitations, assumptions, stakeholders, type of problem, usage, benchmark, what model to test and train. You kind of sorted in terms of thoughts. How am I going to measure my model accuracy? Well, once it goes live, what is my performance measure, right? So since I'm working on a regression model on continuous data, typically I will use root mean squared error. Now, am I going to discuss why root mean squared error? No. I'm probably can upload another video, but I don't think we can go into the deeper because it's primarily focused on the statistical significance of this particular measure. I'm not going to talk about it right now. If you want, we can finish it syllabus. Right. So now you're done with your first block, guys. Congratulations. Right.